Have you ever gazed up at the night sky and wondered, how does all of this work? The stars, the planets, the galaxies, everything we see, and even the things we can't see. What are the rules that govern this vast, mysterious cosmos? How does the universe function at its most fundamental level? Well, today we're going to break it down and dive deep into the incredible mechanics of the universe to help answer that question. Slow music transition. First things first, let's talk about the building blocks of the universe: matter and energy. Everything around you, the chair you're sitting in, the air you're breathing, the stars in the sky, is made up of tiny particles called atoms. And these atoms are composed of even smaller particles like protons, neutrons, and electrons. Atoms combine to form molecules, which make up all the matter we see in the universe, but it's not just about matter. Energy is equally crucial. Energy can't be created or destroyed. It simply transforms from one form to another, whether it's the heat from the sun, the light from a distant star, or the electricity powering your phone. Energy is constantly at work, shifting and changing, but never truly disappearing. Now let's move on to the forces that shape everything in the universe. There are four fundamental forces that govern how everything behaves. Gravity. Gravity is the force that pulls objects towards each other. It's responsible for keeping us grounded on Earth, and it's what keeps the Moon in orbit around our planet and Earth in orbit around the Sun. Without gravity, there would be no structure to the universe. Planets, stars, and galaxies would drift apart. Electromagnetic force. This force governs the behavior of charged particles. It's why your hair stands on end when you rub a balloon on your head, or why light can travel through space. Electromagnetic forces also hold atoms together, and they're responsible for everything from magnets to the way your smartphone works. Strong nuclear force. The strong force is the glue that holds atomic nuclei together. It's incredibly powerful, but it only acts over incredibly short distances. This is what powers stars like our sun and makes nuclear reactions possible. Without the strong force, the building blocks of matter couldn't stay together. Weak nuclear force. The weak force is responsible for some types of radioactive decay and plays a key role in nuclear fusion, the process that powers stars. It's essential for the creation of elements, and without it, life as we know it wouldn't exist. Pause. Dramatic music shift. But how does everything come together on such a grand scale? This brings us to the laws of physics, the rules that govern everything from the smallest particles to the largest galaxies. The most well-known of these laws are Newton's laws of motion, which describe how objects move in response to forces. For example, gravity pulls objects toward one another, and Newton's laws explain how planets orbit stars and how objects move here on Earth. Then we have Einstein's theory of general relativity, which tells us that gravity isn't just a force, it's a warping of space and time itself. Think of space as a trampoline. If you place a heavy object on it, the fabric of the trampoline bends. The heavier the object, the more the trampoline bends. In space, massive objects like stars and planets warp the very fabric of space-time, creating what we perceive as gravity. Pause, music softens. And then there's quantum mechanics, the strange and fascinating world of the very tiny. On the quantum level, particles don't behave like we expect them to. They can exist in multiple states at once, appear in different locations simultaneously, and even be connected over vast distances in a phenomenon known as quantum entanglement. Quantum mechanics is essential to understanding how atoms work, and it's the reason why modern technology, like computers and smartphones, exist at all. Exciting music builds. Now, when we zoom out and look at the universe on a large scale, we see galaxies, clusters of galaxies, and vast stretches of space between them. The universe is expanding. Galaxies are moving away from each other as space itself grows. This was first discovered by Edwin Hubble, who observed that distant galaxies were receding from us, suggesting that the universe began from a single point in a moment known as the Big Bang. around 13.8 billion years ago. And the most mind-blowing part? The laws of physics apply throughout the universe, from the smallest particles to the most massive superclusters. Whether it's the light from a star, the formation of black holes, or the expansion of the universe itself, it's all driven by these fundamental forces and laws that work together in perfect harmony. Pause. Music calms. So how does the universe work? It's a complex, interconnected web of matter, energy, forces, and laws that work together to create everything we see and experience. From the invisible forces that hold atoms together to the galaxies swirling across the cosmos, the universe is a masterpiece of scientific order. The more we explore, the more we realize just how much we have yet to understand. But one thing is certain. The universe works in ways that are both beautiful and bewildering, and we're just beginning to scratch the surface. Thanks for joining me on this cosmic journey. If you enjoyed this video and want to dive deeper into the mysteries of the universe, be sure to like, subscribe, and leave your thoughts in the comments below. Until next time, keep wondering, keep exploring, and keep gazing at the stars.